Hey, what's up, Ziguanas? This is day 3 of the 30 Days of Zig Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. Okay, so first of all, I wanted to say something about yesterday's stream. I didn't see any of the messages on the chat, so I would like to thank the people who were writing something in the chat, but I didn't see any of these. So thank you, Andre, for stating that that operator was about XOR. So thank you for that, but I didn't see in time when you wrote, so I had to do it the hard way. I had to find out on my own. Okay, that being said, let's continue. Today, so okay, this is from yesterday, the code from yesterday where I played with integers and floats. But today, let's start with strings. And let's see, first of all, I already know that there aren't string types in Zig, that this is actually just a literal, but that there isn't the actual string type. So let's see what they say here about strings. If they, yeah, they of course don't even mention them because it's not a type. Let's see if I just search from the beginning. Let's say from here. String literals. Okay, so this is the actual first time they appear. Let's see what they say. They're constant single item pointers to null terminated byte arrays. Okay. The type encodes both the length and the fact that they are null terminated, and because of that they can be coerced to both slices and null terminated pointers. And then dereferencing string literals converts them to arrays. Okay. So source code is UTF-8 encoded. Okay, so they are treated as Unicode. It is possible to embed non-UTF-8 bytes into a string literal using this escape notation. Okay. Indexing into string contains non-ASCII bytes, returns individual bytes, whether valid UTF-8 or not. By the way, before I proceed, I just want to remind, or actually explain for the ones that are watching me for the first time. So I do have a lot of experience in coding, but I've never seen line of Z code before 3 days ago. So the idea of this part that I'm doing now on this channel is just to live stream how I learn a new language from scratch, and how I apply all this previous experience that I had with working as a software developer and also teaching coding. So that's the idea. And then at the end, after these 30 days of challenge learning Zig live, I will create some beginners tutorial, and I will also move on to some more advanced topics. So I will work on some Zig projects and so on. But right now at this stage, I'm literally learning from scratch Zig without any previous experience. Okay, so that being said, let's see what they say here about literals. Unicode code points literals have, okay, this is about integers. Okay, let's play with these string literals here. They're examples that they, and why they use mem. First of all, let's see what they do with the mem, where they use it. I don't see here. Ah, here. Okay. So, okay, I will import that later. I want to go step by step. So let's first of all delete these things that I've done yesterday. And then let's start with this first part and let's see what we are getting. Let's run the Unicode. I've actually done this yesterday, I remember. So this is just to display how the string literals are actually implemented under the hood. So we have here bytes constant with this string here, which has 5 characters. And then under the hood, that's actually the slice of bytes. So this is a pointer, right? That's what they said here. So string literals are constant single item pointers. So that's why star, hence the star, to null terminated byte arrays. So this is a byte array, and we have the pointer to it actually. That's the type. Okay, so it's a pointer to this byte array. And I guess this is the size because we have 5 characters. Now I know from previous experience that when you deal with some non-ASCII characters in UTF, so like smileys and some other languages like, for example, Chinese and so on, so they are not actually using 1 byte per character. So they can have 2, 3, or 4 bytes per character. So I guess this is going to change as we go forward, and we play with some other characters that are not non-ASCII characters, but they are part of Unicode. And then we should probably see here a larger number. So this is, I guess, the size. And then the 0, I don't know what this stands for. They said it's null terminated. Maybe this is a flag for that. Maybe it's something else. Maybe it's the starting point or the offset or something like that in the memory. So we'll see. Let's go step by step. So let's see the next one. This print. Yeah, by the way, I didn't even see that I ran the code, I didn't watch. So this is because I'm actually using the print in this way, and I imported just like in the namespace this std. So I have to use it in this full path way. So I was actually seeing here the output. I didn't see it down there. I thought I saw it. Yeah, now it's showing this exactly the same things down there. Okay. So this is the function. Actually, the method, it looks like the method because it's related. It's with this dot notation, and in other languages, this is a method. So I guess this is a method. Len, or maybe it's an attribute, but actually it's not a method because it doesn't have these parentheses. I mean, some languages you can invoke a method even without parentheses, because there are some things happening under the hood, but actually this could be some static data that is attached to the type itself, so that it's not a method. So it's something like an attribute, maybe. We'll see. So this is how we can get the size of this. So I think this is maybe a weird name because there is also, I mean, yes, okay, it is representing bytes, so it makes sense that you name it bytes. But because it can be also a type, in some languages you have the byte as a type, so that's why it can be confusing. But okay, I went through the types in Zig 2 days ago, and I don't remember seeing the type. So I guess they wouldn't name the variable in such a way that it can conflict with some built-in name. So I guess it's okay. Anyway, so this is just the variable name, bytes, and then if we do the .len, we get the length. Okay, let's see the next thing. Okay, so let's first run it. First of all, let's just double check it works. No. Again, I'm copy pasting, so I'm not doing what I need to do. Okay, so we have, so I guess this is just taking the first, I mean not the first, the second character, the index 1, I wanted to say. The character with index 1. So let's test that. So if I do this, I expect to see L. Yeah, so this is pretty standard. So square brackets and the index of the character, and there you go. Okay, let's get the next one. This time I'll try to remember to type std.debug. Ah, typo. Okay, so we get 0. So maybe this is related to the fact that they say it's null terminated string, not string, but array of bytes. So I guess this is going to contain, because 5 would be somewhere here, right? Because it's 5 characters long. So the last index is 4. So it means that this is probably what they say, the null termination at the end. So let's see if we go to 6. So I guess this is going to break the code, but just to double check if it will. Yeah. Yeah, 5 plus 1. So this is definitely, I think, this null termination. And let's see just if I do something like this, but I omit this 0. See, not here. Sorry. Oh no, yeah, this is the dot, sorry. I'm tired a little bit today, so this is a comment. I didn't write this, so this is just like, by default, it says what it will be displayed. So 5s, we don't have any influence in this, so it is what it is. Okay, so this is fine. Let's see the next one. And let's do this at the beginning again. Okay, this works. So let's see what it is. It asks if character E equals 2 and then escape sequence. So this is now not related to the bytes variable. We don't use byte variable. So I guess this is now not a string literal anymore. It's character literal. It's a separate type. I mean, in some languages it's separated. You have characters and strings. And some others, for example, in Python, there is no such concept as a character, as a different type. So in Python, this would be just like the string with length of 1. But I guess here it's the type is character, so we can actually see that if I do one more print. And let's see what we are going to get here. If I delete this. And if I say the thing that we learned yesterday is this function type of E. Let's see what is the type of it. Compile time integer. Aha, okay. Then I guess this is just like as a literal, maybe it's a character, but under the hood it is just written as the ordinary number, basically the integer that represents the ordinary number of this character in the Unicode, which is 65. Not 65, but hexadecimal 65. Okay. Okay. So I guess you cannot do this because then it would be a string and this is going to break the code, but let's double check. So probably this is a character, yeah. So quote found. What do they say? Okay, this doesn't help a lot, but let me just see here. if they mention somewhere character or literals or something. No. Line feed. So I don't want this to be a boring reading session. So I was just trying to quickly see if we can see something about these single quotes, what they say. Let's see the operators. If we have, so, but this is not an operator, this is a, okay. So it doesn't matter. I guess it is something like a character literal. And under the hood it works as a comp time int. We know that. Okay. So then let's go back to string literals. The next thing, this one here. Actually, let's import it in this other way that I don't have to add the... So we create a variable that now takes in std, but it goes deeper to the print itself so that I don't need to do this. Oops, did not want to completely delete. I just wanted to, let's see if, okay, perfect. I can do this. I can control slash and comment out everything. So let's do the next one. Now we can just use print. Okay, so let's see what this, this is the, I guess, decimal representation. And here we have something that looks like a hexadecimal number, 1F4A9. So we can actually check this very quickly. So let's say x2 decimal. Let's go here. 128, 169. Yeah, I believe it's, yeah, that's it. So escape sequence. And then we have these curly braces and then the hexadecimal number inside, and then we just get the decimal representation because we have D. If I put B, will it work for binaries? Yes, okay. And let's try O for octal. Okay, perfect. So this is then pretty standard. So let's put it back to decimal and let's go back here. So this is one of the characters that is not ASCII. So I guess it's going to be, this will just display the number, the ordinary number. Because they converted to decimal. Okay. Let's do that. Just to try ourselves. Yeah. And I want to do something else just to test what I've mentioned before. So if I say something like, I want this to be a string, so I'll say my string, doesn't matter how I call it, and I want to paste this inside of a string because we know that we have this len attributed or whatever it is, and I want to see how it will show up. So I guess, like I said before, because this is non-ASCII, that this length will not be 1, because it's not about the characters and number of characters, it's number of bytes you take. I mean, that's in different languages. In other languages, it's like that. So I guess it's the same. Ah, my mistake. Copy paste problem. Yeah, so this is what I was expecting. So I didn't know it's going to be 4, but I was guessing it's going to be more than 1. Okay, so this is pretty standard. Let's see here what we're going to get. Oh, nice. So this is like, I guess when you put this U flag that you're getting the Unicode character. So not the number, not the ordinary number, nothing else but the actual character itself. Okay. Let's see the next one. Why this is so weird? Okay. I didn't import this mem. This is going to break now. I forgot to import mem. Yeah. So let's import. Okay, this is used to compare bytes. Okay. Let's run it first, see if it works, and then let's think about it. What does it say? True. Okay, so let's see what we do. We use this object or whatever it is. This type dot, this is a method, looks like a method. Then I guess we are comparing these two things. And this is probably how we, under the hood, how we are treating the bytes or something. So I guess, I don't know, but I guess this is something like, okay, take all these array of bytes and treat them as unsigned integers and tell me if they're the same. So we then compare one by one. So h equals to h, then e, we already seen this before here, where it was here, that this is equal. So when you use the escape sequence, it is under hood equal to the literal itself, and then the rest of them are the same. So I guess that's why. Okay, let's try to change this to 16 just to see what will happen. Probably gonna break. Yeah, what does it say? That's the interesting part. Const uint found. Const, I don't see. Yeah, because when we printed here, we've seen when we printed hello that this is the actual type, that it's the array of bytes that are unsigned integers. But I guess that you still have to here manually say that you cannot omit the type, so that you have to specify that for some reason compiler cannot understand this on its own. So maybe there is some dynamics that I'm not aware of now, that it can change in some cases, so that's why you have to specify. Okay, and then let's go to the next one. So this is again comparing something. Let's see. Okay, what's this? True. Let's see, so we are comparing this one. And because this is 4 bytes, so we did print here before, we know it's 4 bytes. And this is just like saying what is each byte, how does each of the bytes look like. So this is like 111, 4 ones, 4 zeros, and so on. 4 bytes. Okay, that makes sense. Makes sense. see the next one. Okay, so they do say here that the name of the variable is invalid UTF-8. So that's probably why it breaks. Let's see why. So this is, looks like 2 bytes. Aha, okay. 2 bytes, but string literals so far they look like they have to be array of unsigned integers of 8 bits. So 2 of them. Let's see why this doesn't work. Non-UTF-8 strings are possible with X and N notation. Aha, they say this is possible, so it looks like this should work, but it doesn't, or maybe I'm not understanding correctly. 2 non-UTF-8 strings are possible with, so possible with this notation. Okay, what if we do this? What does it say actually? I didn't even read the error. Unusual. Ah, okay. This is what I got yesterday as well. I forgot that I have to use constant. So I have to at least print it out. So let's print out this constant. And then it should work. Yeah, okay, so that's something that I missed. This is the copy-paste problem. So I did forget to do this. Actually, I pasted well, but by accident I deleted one curly brace. Okay. So this doesn't matter what we get. So I just wanted to see how it works. So we can define a non-UTF strings with this notation even. Okay. I mean, we've seen here that this didn't break, so this is already something that we could have expected. Let's see the next one. Okay, let's see what happens here. Okay, it does use the same variable from here. And then it takes the second element, the one with index 1. And then we say OX, and then we have the hexadecimal value of it. So FE, so the second one, yes, this is the second one. Okay. Okay. Nothing too weird there, as expected. See the last one. Aha, this is also taking the second. So we should see something like 9, yeah, 9F. The same thing. Okay, so this is pretty straightforward. So to summarize, we have this len. I think it's an attribute that we can use to get the length of the string. Actually, yes, it's a string literal, but under the hood it's array of bytes. Then we can use the square brackets notation to take any specific byte out of it. Then, okay, this is the same. So here we use this single quote notation, which I believe it's a character literal, which under hood works as comp time int. That's what we've seen when we printed the type. Then we use this d in interpolation here, which basically gives you the decimal form of some number. In this case, it was hexadecimal. Then we tried, I remember playing here with also binary and octal. Then we started using these special characters that are taking more than 1 byte. Then we did these last few things where we took the specific byte of these special characters, which consist of, so this is actually cool that you can take the 1 byte of a character that is actually 4 bytes. So in some languages you cannot do that. You cannot just like stop in the middle of the character and then take. Yeah, but that's why Zig is low level. Okay, let's see what else is here about strings, what they say. Okay, arrays and source encoding. So this is when we go deeper into the type itself. New line, okay, standard, carriage return, tab, backslash, single quote, double quote, yeah, pretty standard ones. Hexadecimal, 8-bit byte value, 2 digits, and then if it's more than 2 digits, so if it's more than a byte, then you have to use this form with curly braces and U. Got it? I will probably forget 5 times before I start using it more, but for now I've got it for now. Not the maximum value, the Unicode scalar value is okay. This is Unicode, not Zig specific. Multiline string literals. This is interesting. Multiline string literals have no escapes and can span across multiple lines. To start multiline string literal, use this double backslash token. So this one, just like a comment. So they actually don't put it under the quote. So this will work. These escape sequences will work under the quotes. But I mean, that's at least how it's in other programming languages. So I don't see why here it would be an exception. But it looks like here that you don't use double quotes to start a multi-line string. Okay, so you use this instead. So I will try that in a second. I just want to finish reading what this says here. To start a multi-line string literal, use the, okay, just like comment, the string literal goes until the end of the line. The end of the line is not included in the string literal. However, if the next line begins with 2 backslashes, then a new line is appended. The string literal continues. Okay, got it. So if I understood correctly, you write one line like this without these other lines, it will be just this part will be a string. It will not include the new line. It will not include this character here. But if you write more than 1 lines in this way, then they're actually going to, so for example, if I have only these 2, I'm going to get this as a string, plus I will get backslash n at the end of it. And because this is the new line, and it doesn't, so I'm now pretending that I don't have these, then because the second line just contains 2 backslashes, that will just basically create that backslash n character here, and that's it. So I will not have any more characters in a string. Okay. Let's just try to play with this, just to test it at least once. So let's try first this first theory that I had, and let's make it shorter. We don't need to have all these, just like few characters. So let's put A, B, C here, doesn't matter. So this should be 4. So actually first let's delete this, that we have only 1 line with backslashes. So this should be a string. Hello world in C. And then let's print here. So we want string first of all. And I just want to do this. And what I want to do after is just to have the name of the string .len. Right, this is everything we need. So because this is made as a multi-line string, but without actually creating the second line. I expect this to be 4, right? Is it before? I forgot if it, yeah, when it says the length here, it gives you 5, which is the number of characters. I'm just trying to remember if it includes the null termination as the length. So it shouldn't, and it doesn't. Here it was 5, so then in this case, the null termination doesn't count, so we should see 4. If I guessed correct. I mean, if I understood correct what I just read in the documentation. What does it say? Oh, yeah. Let's see. Yeah, 4. And now if I just create another line and do this, now it should include \n, and the length should be 5, actually. What does it say? Yeah, 5. Okay. So that's how I understood. Okay, this is something else. Okay, so this is everything about strings. String literals, more like string literals. Let's go back one step back here, just to reread this one more time. What they say about type itself, not the literals, but under the hood. So it encodes both the length and the fact that they are null terminated. This can be coerced to both slices and null terminated pointers. The reference, okay. Because Zig source code is UTF encoded, and in okay, this is, we went through this, but I just wanted to see. Give me just a second to see here. One more time, what did I do? Yeah, this is the actual type. So the pointer to array of unt slice. Let's see what they say about string literals, converts them into arrays. Dereferencing them. Okay, and I guess they are dereferenced when you want to do something with them, when you print them or something. They are dereferenced. But let's see first, this is when they are not dereferenced, when they are slices still. So let's see how, I don't want to speed up. How long did I speak today? So if I started, this is already too long, so I don't want to start a new topic because this is going to take some time. And I don't want to do this now. So okay, we can finish it here. And we can continue tomorrow. Okay, so probably tomorrow I'm going to continue with booleans and conditions before I actually jump into slices and these more complex data types, because I still haven't covered this basic one, booleans. So, and booleans are short generally, so I will probably have more time to play with conditions and these basic boolean operations. So that's kind of the plan for tomorrow. Thanks anyone again, I said anyone. Thanks everyone for watching, and see you tomorrow. Bye bye.